type in add call to parent function. Now it is going to call the C++ version. Now if I go ahead and press play, as you can see, it calls the C++ implementation, the blueprint implementation as well along with it. So that is basically how it works. Now if you were to do this, as you can see, we call the C++ function along with the parameters, of course, as well as the blueprint function. What you are calling here is actually the blueprint function. If it does not find an implementation, it is going to use the parent class version of the function. Remember that. So until now, we actually discussed everything which was foundational in order to actually start developing in C++. However, we do lack a little bit of knowledge regarding, the implementation of various data structures in Unreal. Now, apart from just using normal variables, you would use arrays and maps. There are others such as sets, linked lists and stuff, but for games, you would honestly just use arrays and maps most of the time. So in order to implement arrays in Unreal, so you don't use a static array. I mean, well, you could, but you don't use static arrays. You don't really use the std vector as well. You could use std vector, but you can't expose them to blueprint and stuff, or you would have to write your own wrapper class. Now, if you guys don't know what I'm talking about, I'm basically referring to the standard template library in C++. But in Unreal, instead of std vector, we actually have another type known as template array or tarray. So the way you create that, so let's create a variable in C++. Let's do that in the public section. We're just doing it for demonstration. So I'll just make a u property and make this one blueprint read write and edit anywhere. So edit anywhere, and over here what we can do is, instead of, let's say we have an array of integers. So the way you do it is you type in tarray, and as a template argument you would give the type as integer, and let's just call this rint array. Alright, now template array is actually internally something like your std vector. So if I actually control click on this, this is actually a class which implements it. And the methods which are associated with this are pretty simple. We will go ahead and check all of these. So similar to the std vector class in standard C++, tarray has a bunch of functions which gives us info about various things. So let's actually set some stuff up. So in order to initialize this array, so what we do basically, we can do it in the constructor or right here. We'll do it in the constructor just to keep things clean. So we'll call rint array equals, and within curly braces we can just give some values. So I'll just initialize it with some random values. Alright, so now let's go ahead and look at how to add stuff to this. So similar to add and emplace, we have methods for that over here as well. So we can type in rint array dot add, and now we can go ahead and add an item. So let's say, for example, I want to add 12. So our fifth element here, that is at index 4, is going to become 12, and this array is going to be resized since it is similar to an std vector. Now similarly also have emplace, so constructing an element in place basically dot emplace. This is like your emplace back function in std vector. So I'll just add in some random element over there. Now our array is going to be 23, 6, 43, 64, 12 and 4. Now what if I wanted to remove something? So I can type in rint array, and I can remove either at index, so dot remove. I can either remove an element by using the remove function. So let's say I wanted to remove 23. I'm going to remove 23. And rint array, rint array dot remove at is going to let us remove something at a given index. So let's say I choose 0. So now it's going to remove 6 because we already removed 22. So 6 is our first index. So 6 is going to be removed. Alright, so we did all of these, but now what if we wanted to reserve some memory for our array? So what if you didn't want it to resize and search for memory? So even those functions are available. So let's call the reserve function before all of this. So our int array dot reserve, reserve, and as we can see, we have 4 elements, 5, 6, and we remove 2, so we have 2. So we can reserve 4, but at max we have 6 elements, so let's reserve 6. So we can call that and stuff. So these are the most common ones that you'll use. You won't really use all the other methods, but again you can just refer the documentation if you really need it. Now we can go ahead and iterate through this array through a range based for loop, just like how you can with any of the STL data structures. So we can go ahead and do a for loop auto. We can just call this one element, and we can pass in the array just like how you would pass an std vector. So r int array, and what we can do is we can go ahead and print it out by calling the print string function. So you Kismet system library print string, you know the drill by now. So now in order to print an integer, you actually use this function which is a static member of the fstring class. So fstring from int is what you use, and you can go ahead and type in le here. Now remember, if you wanted to print a float, you would use this function known as sanitize float. Now it's going to cast it implicitly anyway, so even float works for this. And you also have other functions for converting between various data types. You could again have a look at either the fstring class, or you could go ahead and just search it up on the documentation. So if I actually head in over here, so we have our sanitize float here. We have to hex blob, from hex blob. We have various functions basically. So we have from int, as you can see, you can go through this class, see the return type, and look at what the function does, and then you can go ahead and implement it accordingly. So now I'm in the editor. If I open up my BP character, and if I actually head back over here, we had made this blueprint read write, so we should be able to access our int array. So if I just type in our int array, so as you can see, we get it just like any other blueprint variable, and since we initialized it in a constructor, we already have certain values. Now in begin play, if we go ahead and iterate through this, so I'll just do that. We'll not call this function anymore. Now we have an idea of what that is. So we have already set it up actually. So we've done it over here. So we're printing stuff in our begin play in C++. So we don't have to set it up actually. So if I go ahead and press play, as you can see, we have 4, 12, 64, 43 in reverse order, that is 43, 64, 12 and 4. And let's actually walk through the logic. So we have 23, 6, 43, 64, and we went ahead and added 12 and 4. So 12 and 4 should be our last elements, and we removed 23 and we removed 6. So our array should be 43, 64, 12 and 4. And if we go ahead and look at our logic here and our output, so we see that we get 43, 64, 12 and 4. So this is basically how you use the tarray class functions. So this is exactly the same as your std vector, but there are a couple differences in the function names. And most importantly, from a readability perspective, all of these functions use Pascal case, so it's readable compared to the standard C++ stuff, which uses underscores, which is not really that readable. So this is how you would iterate through an array. Obviously, you could use a full-length iterator, but there is no actual purpose to do it as per my experience. Anyways, let's head into the next part now and take a look at how else we can iterate through this through your standard C style for loop. So I won't be actually showing you guys the output since it's obvious that it's going to work. So you would just do something like for int I equals 0, I less than, now this is where we talk about another method in this class. So we do I less than rIntArray.num. This is similar to the size function in the standard template libraries std vector, and we can do I++. So we can just increment I. Could do I++ or I plus equals 1. Now instead of LE, since this is not a range based for loop, we can get rArray and we can get the ith element. Now this is going to work exactly the same. Apart from arrays, the other data structure that you would use in a game is going to be maps. Well, there are linked lists and other data structures which you really won't use that very much in games. Even maps, to be honest, you just use it maybe a couple of times in your entire project. But anyways, in order to create a map in Unreal, basically you use the type tmap. So if I just copy over the uProperty macro, and in the next line we can go ahead and create a map. And if you guys know about maps, basically it's just a key value pair. So for example, you can have two strings as key and value, and you could have something like a username password key value pair, something like that. So let's just create a simple one. Let's say we map a string to a float. So it's case sensitive, obviously. And we can call this one rmap. Now you can't just initialize a map like how you would initialize an array. So you would have to call the add or the emplace function multiple times. That's just how you would do it. So rIntArray, or rather rmap dot add, and what we can do is we can pass in the string and the float. So let's say pi and 3.14. Then we can go ahead and call add once again. So we'll just go ahead and do all of this in our begin play. So let's just find some other number. Let's say num1 for example. Let's just grab in a random value. Now once that's done, you have other methods, but you aren't really going to be using them for anything. But I'll just show you guys how to iterate through this and how to retrieve the key and the value. So that's what you'll be using this most for. Now let's say you wanted to access an element though, you could do something like this. So let's just print out what the index num1 will contain. So copy this over, and instead of rIntArray of I, what we can do is we can get rmap of num1. Basically num1 is the key here, and basically by doing this you're getting the value of it. So in our case we mapped num1 to 43.4543, and if you want to iterate through this we can use a range based for loop here as well. So we could just say auto element, and we can pass in our map. And what we can do is we can get the element. So we'll print this. So we'll copy the code over once again. So we'll print both the key and the value. So let's just create a string variable temporarily. And the way you get the key of this, so each element in this map is going to be a key value pair. So LE is going to be a key value pair. What we can do is we can do dot key in order to get the key. And if we want the value, we can go ahead and do le.value. The way we'll do that here is we'll just append the string. So basically we'll concatenate the two strings. So what we can do is temp.append, and let's just put a colon just for visual purposes. And we can do temp.append, and since our value is going to be a float, we can do fstring sanitize float, and we can go ahead and get our value. So le.value, that is going to be a float. Now we can go ahead and rather than printing this, we can go ahead and print in temp. So we also learned how to concatenate strings on the way. So this is how you would iterate through this. This is how you would get a key of a given element in the map, and this is how you would get the value. Now remember, you cannot have two keys of the same value. So let's say I actually create another element with the key num1. It's going to throw an exception. You can't actually do that. So now we'll actually stop printing our array now that we're done with that. So if I go ahead and run a debugger now, since everything is set up now, if I go ahead and press play, you would see that we get pi 3.14 and num1 43.4543. And as you can see, we also get our 43.4543 that printed first because we had printed our map of num1. So basically the key here is num1 and we basically asked for the corresponding value. It is just as if you asked for our int array of 1. It's pretty much something like that. So basically instead of the index you would pass in the key. That's basically how you use this operator here. Now this is basically how you iterate through it. Now you could, do many other things with a map. But for the most part, you'd just be using it to store key value pairs. Generally, it's useful for having a track of, game users and stuff like that. They're really very odd use cases for maps. You wouldn't really use it that often. So I'll leave this over here. Now, when it comes to designing your game, once you're actually aware about all the things that we just discussed over here up until maps, in order to actually implement them in an appropriate and efficient manner, you would use the classes which the engine provides us. So we'll be going through some of the most important ones which will be used in all of the games, and there are other derived classes of it. The ones which I showed you guys in the flowchart previously, when I showed the inheritance hierarchy, those are the ones that we will be discussing in detail. There are other classes, we'll just be brushing through few with whichever are important, but if they're not, we are going to be just skipping through them. But if we ever use them in the last part of the course, we'll be having a look at them in depth once again. So now let's start talking about actors. Now at this beginning of this video, I actually talked a little bit about actors. Basically anything that can be placed in the level is an actor. So that definition still holds good, but it is incomplete. There is another thing which an actor can do, and that is it can tick. Now you guys have probably seen the tick function. So let's open up an actor actually. Let's create one because all of these have their own base classes. So let's create a pure actor in Blueprint. We'll do one in C++ as well pretty soon. Or actually we probably have it. So let's call this one BP underscore A, let's say. I just created this for the sake of it. Now if I were to actually have a look over here, you would see that you have 3 tabs and the event graph is where you worked on for the most part. But we haven't actually gone in depth into all of these little details. So first let's actually go from the top. So what we have here is the class settings, and most of the times you'll just use it to implement an interface or change its base class, but other than that you aren't going to be using it. Now under class defaults you have a bunch of things which actually define what an actor actually can do. Now if you were to look at actor tick, you have several options. Start with tick enabled, tick interval, and you also have several other things. Now we did talk about this one, so I'll not be talking about that. But anyways, all of these are self-explanatory. And one thing which you won't see in any other type of blueprint other than actors is the replication tab. Basically, if you check this replicates tab, this actor will be eligible to be used in multiplayer. What I mean by that is that when you spawn this on the server, which we will get to when we talk about multiplayer, basically all your other clients can see it too. By clients, I'm referring to players in this context. And we have settings regarding that. Now these are just the flags. These are pretty self-explanatory, hidden in game and visible, stuff like that. And under the collision tab, these are things which we again talked about. But there are a couple more things which an actor provides us. The first one is your damage. Now, if let's say you wanted this actor to be destroyed, so let's actually do that. Let's go ahead and create an object. So let's add in a model here. So let's say we add in a sphere. I don't know, maybe simulate physics on this, or let's leave it as is. What we can do is Unreal actually provides us with default logic to apply damage to this. So if I type in event damage, you see we get 3 of these nodes: point damage, radial damage, and any damage. So any damage is going to refer to all types of damages. Point damage is going to be your damage through a line trace or something generally. Radial damage is going to be something where you damage this actor through a grenade or something like that. So you would have a distance and stuff like that. So if I just press this, so you have your origin, so that's going to be where your grenade landed, for example. So it need not be a grenade, could be anything else. Just give an example. So from that point, if as you go further away, your damage is going to decrease, stuff like that. So let's just do event any damage. So any damage. What we can do is over here, we can go ahead and simply print this out rather. Just to demonstrate that this actually works. Now, by default, Unreal does not give you any health variable. You got to do that yourself. And one thing you might have noticed is this little icon over here at the top right hand side of any damage. Basically, that property is called blueprint authority only. What it means is that you can only call this on the server. So you cannot call this on the clients. Obviously, you don't want your players to be handling the damage and stuff. But anyways, let's actually go ahead and work on this logic. So when we left click, we do the line trace thingy. So let's bring up the line trace logic once again. So what we can do is we can line trace by channel, and we get our camera manager, get player camera manager, get the actor location. This is some stuff which we've already done. Then we get the forward vector, and we multiply this by a certain value. So let's just convert this to a float, and let's multiply this by, let's say, 50,000. We are going to add this together, and we can plug that into end and the start. And from our out hit, we can go ahead and call apply damage. So there are multiple nodes: apply damage, apply point damage, and apply radial damage. We'll do apply point damage. You could just do apply damage, and base damage, let's just give it a value of 30. Or just to keep things a little more interesting, so random float in range. So let's just say anything between 20 and 50 maybe. So it's just going to select a random number. And damaged actor is going to be the hit actor, obviously. And damage causer is going to be self. Damage type is something we won't be talking about. And hit info, we could just pass in this whole hit result. So what we can do is, instead of doing this, we can recombine this, pass this in here, and we can go ahead and break this separately. So type in break and pass the hit actor once again to the damage actor, and we can collapse this as is. Hit from direction, basically that is going to be something which isn't really going to affect your damage, but once you know the damaged actor's location, you can actually find the direction towards it basically. So what we can do is you can do something like this. So basically use this node called find unit direction. So unit direction. So get unit direction. So it's going to be from our start to our location, and this is going to be our hit from direction. So basically this is a position vector and this is a position vector as well. So we can subtract it to get a vector joining those 2 points basically. And now it should compile. If you really don't want to use this, you can go ahead and split this, and this is going to work as well. It's just going to construct a vector in place. So we'll recombine that and use that. And if I go ahead and press play, nothing's gonna happen, but if I actually drag our BPA here, and if I go ahead and press play, so as you can see, we are applying some random amount of damage. So not sure why the lag exists, but anyways. Now once that's done, the next thing that an actor provides us, and also just one more note here. So now we're talking about the blueprint version of this. We'll also look at C++ stuff a bit later. There are a few things that I would like to go over in C++ as well. So the next thing is hit events. Now remember we had done the overlap for a character. So somewhere over here. So similar to that, you also have hit events. So you just type in event hit. And this is how you set up hit events. You also have hit events for each individual component. So if I click on the sphere, if I scroll down, I can actually do on component hit as well. That works too. Now other is going to be the actor which actually hit this, and other component is basically the component of the other actor which hit it. My component is going to be the component in this actor which actually hit the other actor, and hit location is the hit location, of course, and we also get a hit result. So way too much for what you need. So that's generally the reason why when I actually work on these things, I just create an interface myself, because generally you really don't require all of these things in order for your damage logic to work. Anyways, I'll show you guys how this is gonna work. So if I just go ahead and print this, and one handy node here is you can actually get this, and if you can type in get display name, and you're going to get the display name of the object. Basically, if my character bumps into this, so let me do that real quick. Okay, I can't, it's too high, so let's bring that down. So if I actually bump into this, as you can see, you get BP character. The reason it's printing it so many times is because we are in contact with it for quite some time. So when we are in contact and we are sliding on it, each frame it counts a new hit. Basically that's the reason it's happening. Alright, so the next thing that I would like to touch upon when it comes to actors is the construction script. So this is similar to your default constructor in C++. Now there is a way to actually get an equivalent of a parameterized constructor. I will get to that both in Blueprint and C++. But first let's work with this. So let's say I drag this in. Now every time I update this actor, the construction script is actually called. So let me just show you guys. So if I just go ahead and print string, and if I go ahead and move this actually, so first let me compile that, save it. Now if I head back, as you can see, every time I move it, it actually prints hello. Basically, every time you spawn this actor or you update this actor in the level, this construction script is called. At runtime, it's only going to be called when you actually spawn it. But over here in the editor, whenever you move it, it's going to be called each time. There's actually an option somewhere in the class settings. So run construction script on drag. So you can disable that if you don't want that to happen. So it's only going to call it once you finish placing it. I'll just leave it as is. Now if you want a parameterized constructor, basically let's say you wanted to set a variable. So let's call this, I don't know, maybe some float variable. And we'll make this of type float. Now if you want to actually set the value of this outside like a parameterized constructor, first select this variable and head into this option right there. Select instance editable and expose on spawn. Now what you've essentially done is you've basically exposed this when you actually call the spawn actor function. So if I just head into my character and spawn this on begin play, so I'll just leave this BP pickup and let me just do this actor instead. So BP underscore A. Now health points is not a parameter, so you can alt click that to delete the pin. Now as you can see, we can select some float. So I can set this to whatever I want. Now this is something which we touched upon. However, there is an equivalent of this in C++ as well. But it is a little more complicated than this. So if we actually head into our Visual Studio solution. Alright, so now that we are in C++, now let's actually test it out with our cpp underscore actor. So let's go ahead and spawn this from our character, or if we have anything else we could try that as well. So our interaction actor maybe. Yep, we could try that. So we can spawn our interaction actor. Now if we go ahead and head in here, inside our characters header file, so we can go ahead and include that as well. So hash include, and we can go ahead and include cpp interaction actor.h. Now let's actually create a function, or we can do it on begin play. So head into begin play. Now after we are done with this, or we can actually just remove this logic, we aren't really using this. The way you spawn actors in C++ is by calling the spawn actor function from world. So in order to get your world, you call this function known as getWorld. And from here, you can go ahead and call spawn actor. And this actually takes in a template argument. And this is going to be the type which this spawn actor function will return. So this is going to be a cpp interaction actor. And we could just spawn it like that. It's going to take in all the default parameters. You can actually set up subclasses and stuff. So let's say instead of cpp interaction actor, you wanted to spawn some derived class of it which is there in blueprint. You could do that totally. So let's say I wanted to spawn bp interaction actor and not cpp interaction actor. So we can actually test that theory actually. So bp interaction actor spawned. I mean, the spelling doesn't really matter here. So let's delete whatever's there in the level. So bp interaction actor. So interaction actor. So I'll just go ahead and delete that. Now if I press play, I'm not really getting that. So what we can do, this is going to spawn your cpp interaction actor. But if we actually have a variable here which stores the exact class which we are spawning, so we can do that right there. So u property, make this one edit anywhere, and make this one blueprint read write as well. Now what we can do is we can go ahead and pass this in. So the type which you use is t subclass of, and obviously we are looking for a derived class of a cpp interaction actor. So we'll just copy that over. So this is going to be prefixed with an a, and we'll call this one class to spawn, or rather we can call it actor to spawn. Now this will be available to us in our blueprint. Now one thing to remember, you have to make sure it is actually valid. So if our reference is valid here, so our subclass is basically, so if this class reference, so if actor to spawn is valid, only then we are actually going to be spawning this actor. And over here in the arguments list, you can go ahead and pass this in and paste this in, and you can also pass in a transform optionally, but I won't be doing that. Now let's actually pass in some parameters. So if you want to pass in a parameter using your deferred spawn actor, as I would call it, as the function is called, so we can actually do that with the same thing. So let's create a variable here which we would want to edit. So under the public section, we can go ahead and create a u property. We don't need this to be blueprint read write or anything, so we can call this one int some variable. And the way you would set default values for this is if I go ahead and write the function again. So this is how you'd spawn an actor. Here you would have what's going to be returned. So if I actually do auto temp equals spawn actor interaction actor, basically this temp will be of type ACPP interaction actor pointer. So a pointer to the spawned actor will be returned. Now what we can do is we can spawn another one actually. So we'll just do auto temp1 equals, we can just go ahead and copy this, and instead of this we can do spawn actor deferred. And just make sure you get the spelling right. So spawn actor deferred. So for this one we have to pass in the transform, so we can just write a constructor over here. So f transform, and that should compile. But once you call this function, the actor is actually not spawned. Now since we have a pointer to our actor, we can go ahead and call this function known as finish spawning. So if I type in finish spawning, this is going to actually complete the spawning process. Now you can just again pass in the default transform. So once this is done, our spawning would actually be complete. And in between this is where you can actually set your variables. So you don't have a parameterized constructor, but now we can go ahead and set our sum variable. So sum variable equals 100. Obviously temp1. And now what we can do is in our interaction actor, we can go ahead and just print it on begin play. So u kismet system library print string, and we can go ahead and continue with this and go ahead and print in f string from int, and we can pass in our value here. So sum variable is what we want, and that should be about it. Now if we go ahead and run a debugger here, everything should work as expected. Just make sure you close the editor before you actually build it. So now if we go ahead and press play, we shouldn't see any print strings, and this proves that our if check here is actually working. If we would have removed this if check, our engine would have crashed, since this actor to spawn class reference would be invalid. Anyways, we can set that since we have exposed it to blueprint. So in our character, I assume, so this is in CPP character, so it's going to be inherited into BP character, and under your class defaults over here, you should be able to find your variable. So CPP character, under the third section here, actor to spawn, and we can select our BP interaction actor. If I go ahead and press play now, as you can see, we get two prints along with 10 and 100 for our spawned actors. Now the first one says 0 because in our first spawn actor function we actually didn't set any of the values. So this was our classic spawn actor. And in the second one we actually used the deferred spawn actor, which let us set the default values before calling the construction script. So this is basically how you would simulate a parameterized constructor in Unreal Engine in both Blueprint as well as C++. Now the next class that I would like to mention here is going to be the character class, and we have used that quite a bit. So if we just open up our BP character, for example, which is a character class, so we have inherited it from CPP character. Just to keep things clean, I'll just create a new character here, and let this just be called new character maybe. Now open it up. Now if I were to just look at the parent class, it says character, and character is actually a derived class of pawn. So basically every character is a pawn, and pawn is a derived class of actors. So when I'm talking about characters, I am collectively referring to both pawns and characters basically. every character is going to be a pawn. Now, the reason why I especially wanted to mention this, even though this is technically just a derived class of actor, and probably many other classes which I'll mention further are derived class of actors, is due to this character movement component. Now this allows you to do various things. Now if you were to just go ahead and look into these parameters, you can actually have a pretty basic idea on what you can do. At the beginning of the course, if you remember, I had mentioned that you can actually use functions to modify almost any of these values, not all, but most of these values at runtime. So for example, now let's just take our BP character for example, and let's go ahead and press play, and we know that we're using this. So we're walking forward. But what if this feels a little bit too fast for you? Now this is where our character movement component is going to help us. So the maximum speed of this character is actually set by a variable inside here. So if I just drag this in and if I type in set max walk speed, as you can see, we are able to set some value over here. So I'll just do this on begin play. You could do it somewhere else as well. But let's say we wanted him to go only at 500. Default is 600 by the way. Now if I go ahead and press play, you see that he moves a little bit more slowly. Now if you feel this is a... Now one more thing is that the animation will also slow down along with his speed. So that's not something which you should really be seeing in this example. So we are moving slower. Let's say we wanted him to move a little more fast. So let's say we have 1000. We can go ahead and set the speed, and now we walk much faster. So stuff like this. And one more useful thing which the character movement component provides us is movement modes. So if I just type in movement mode and get movement mode, you can actually see this is an enumeration. We can just do a switch to see what are the enumerators here. As you can see, we have walking, nav mesh walking, which is for AI basically, falling, swimming, flying, and custom. Now there are various things you could even do with this. Apart from switching between them, you can actually set the movement mode. So for example, if I just change this to flying for example, and if I go ahead and press play, now you would notice that this behaves a little bit differently. Now if the movement mode is flying, if I go further, as you would see, he's actually floating in the air. So when you actually set this movement mode to flying, basically it also allows you to take vertical movement input. So apart from your move forward and backward, you could also do up and down. So let me actually do that. So where we have our add movement input, instead of forward, if I do up vector, so get actor up vector, if I just do something like this, and if I go ahead and hit W, as you can see, we can actually go up and down as well. So this is something cool which you could do. And there are a few functions which I would specifically like to talk about right now. And one of them is launch character. Launch character. So let's say I wanted to implement a jump pad or something. So let's just do it after a delay. So delay of about 2 seconds. And we can go ahead and give something for the launch velocity. Let's just give 10,000 maybe. Now if I go ahead and press play, as you can see, we were launched in the air. I mean, I just gave a really high value for the launch velocity. Let's say we give something like 3000 maybe. If I go ahead and press play, as you can see, we are launched in the air. So if you had something like a jump pad or something which you wanted to implement, this is a really cool way to do this. And the best part about all this is actually networked by default. Most of this logic, if you just run on the server, is just going to run well for multiplayer as well. So that's one thing. So launch character and stuff like that. There are actually many other functions which you would have access to. One way to actually take advantage of the context sensitive menu is if you just drag off of self, and if you can just head into character, you can actually look into various functions over here. This is what I find useful. you can apart from launch character, few more functions which I would like to go over are crouch. So if you set your movement mode to crouch, and make sure you have you can crouch, so there should be an option somewhere here. So crouch should be under character movement, can crouch, make sure that is true, otherwise it's not gonna work. Make sure this is true, and if you go ahead and hit crouch, and one thing that I would like to show you guys is by setting this hidden in game to false, so let this be visible in the game. Now if I go ahead and take a look at this, as you can see, everything seems normal here. Let's actually just disable some of this logic. Alright, so I'll go ahead and crouch. So if I go ahead and crouch, as you can see, our capsule, whatever we had, is actually shrunk. This is basically your collision now. So let's say you couldn't pass under some things, now you can actually. So I'll just drag this a little bit below average character height. So let's say about this much. And now our walking speed is also very less, even though we set it to 1000 manually. Now as you can see, our collision is only up to the capsule. You can change the height, by the way. So if I just type in crouch, I should find crouch half height. You can actually increase that, no issues with that. And as you can see, now this has a separate max walk speed. So stuff like this is already implemented for you in the engine. Now all you have to do, if you really want to learn more, is just browse through this list. Just look at something which might be useful. So let's say you're doing multiplayer, you could have a look at this. Now this is not something which would really be that helpful, to be honest. But there may be a few settings which you might actually find helpful. Now there are many more things which you can do, and if you aren't able to actually write a certain mechanic using these, 9 out of 10 times you're just doing it wrong. It's just 1 out of maybe 10-20 times that the engine is actually deficient of features. So just like this, you could go ahead and explore this for yourself. All of those parameters which we saw in Blueprint are also accessible in C++. There is nothing special really. So for example, let's say I wanted to crouch, so I can just type in crouch. As you can see, the method crouch exists here as well. And not only that, if I want to access my character movement based functionality, there is actually a get function for it. So get character movement is the function name. So this is going to return a U character movement component pointer. So once we actually have access to that, so let's say auto temp 2 equals, okay, it's in a different scope, so we can reuse temp. So auto temp equals get character movement, and now we can use this variable in order to just call our regular functions. So for example, if we want to change our movement mode, so we can type in whatever the function was over here. So movement mode. So set movement mode was the function name. Set movement mode. Now clearly it's not happy with us using this type, but fix for this pointed to incomplete class type. So the simple fix for this is to just look up the documentation for the header here. We don't have the character movement component header file, so we'll just paste that in our .h. And now if you go ahead and look at this, this should work. And now we get the options for the parameters. So for this, let's actually type in E movement mode. And we have move flying, for example. And then new custom mode, we can just set this to 0. So like this, you can set the movement mode in C++. So stuff like this is going to be analogous to both Blueprint as well as C++. However, note that some of these headers aren't actually included by default. So make sure you just go ahead and include them before you start working with them. So we are inside the BP player controller class, and we have dealt with this before, but going a little bit more deeper, player controllers or controllers in general are designed to handle input. So if we actually bring in an input binding, so for example, I just type in W on the keyboard. So what's going to happen is this input will actually be taken over our input bindings which we set up in our character. So if I just print a string, we'll actually not move, instead we'll be printing hello. So that's one thing to note. Other than that, the mouse interface has several important functions such as show mouse cursor, enable click events, enable mouse over events, and stuff like that. All these are self-explanatory. One thing to note is that your pawn or your character obviously is going to be possessed by a player controller, and without a player controller you can not actually control your character. And all of these are actually set inside your game mode. So which player controller class you use is decided by your game mode class, which we will talk about soon. Game mode, game state, player state, and player controller, all of these work in conjunction. A player controller is going to possess a pawn which you can control. Now once that's said, there are a few other functions which are important here, such as set input mode game only, which will take your game input basically. And when you have set input mode game and UI only, so in that case you are going to be able to interact with widgets as well as take player input in the game. Similarly, UI only is going to disable your keyboard input entirely. So stuff like that, functionality regarding input is available in your player controller. Despite using all of the above mentioned classes, it is technically impossible to set up a well playable game. So we have a few more classes which actually set up the whole framework to actually start developing the game logic itself. And those are game mode, game state, and the player state. Now the player state isn't that important, but the game mode and game state will provide you with all the functionality that you need in order for your gameplay logic to work. So we have already created a game mode. Know that every level will have one game mode and you have to set that. And the important part here is these classes. These can be set over here in the world settings. And a pawn class is as expected BP character. However, this can be changed at runtime, in the sense you can possess a different pawn. The default is going to remain the same, but you can call the possess function on your player controller. So let me actually show that. So let's say I'm on new character right now. So now I can't move or do anything. However, if I head into my game mode, and let's say after begin play, I just give a delay of few seconds. So delay, and I give let's say 3 seconds or 2 seconds, and I get my player controller. Now note, this is a single player game, so this works. Otherwise, anything that you do will be with respect to the server. Game mode in a multiplayer game will only exist on the server. That's one thing to note. So from here we can type in possess. And what we can do is we can just spawn a character. So where our player start is, we can just copy this over, let's say. Or we can have a target point instead. So just type in target point, drag this in, and get the location. So we have something like 10, negative 11,420. So head into the game mode class, spawn actor, select BP character for example. So BP underscore character, and for the transform, negative 11,420, and we'll do 350 for the Z. And for the pawn, this is going to be the pawn which we will possess. Now if I go ahead and press play, wait for 2 seconds, And as you can see, we have possessed our BP character. So stuff like this you can easily set up in your game mode. So anything such as this which is handled on the server is done in the game mode. But the game mode isn't really limited to this. The game mode has several functions such as post login, and you also have other things such as on logout. So this is basically when you join the game in a multiplayer game. This is basically when you leave the game or you disconnect. So you'll still have all the references available to you. So that's where you'll use the game mode. So basically you'll use this for stuff which is core to your game logic. However, let's say you wanted to store something like a timer. Now the timer has to be in sync with everyone. So obviously it has to be on the server, but all your other players must be able to read it at least. So in that case, you use a class known as GameState, which does the exact same thing. So if I just type in GameState, I'm going to use GameState base. GameState is basically GameState base with a few extra functions. So let's call this one BP underscore GameState. Oops, BP GameState. Open it up and ignore the viewport and stuff, doesn't really matter. And once you have this, over here we can have something like a match timer. So I'll create a new variable and call this one timer. So I'll make this of type integer. Over here we can go ahead and start the timer. So set timer by function name. We can go ahead and create a simple custom event here. So custom event, and we can go ahead and call this one, for example, timer increment. We can copy the name, paste that in. We want it to run every 1 second. We want it to be looping, and it has to run till the end of the game. So we can do timer plus plus. Now this value of timer over here can be read by your widgets and stuff like that. So there's actually a function which you can use for this. So let's do that in our widget. Head into your UI, HUD, BP HUD, and where we have our stuff set up. So let's actually revert our character settings. So change the character to BP character, and over here for the spawn actor as well, we'll remove that for now. For now we'll forget about it. Over here where we actually create our HUD, this is where we have our reference. So what we can do is we can actually create some more text here. So we can type in timer. So whoops, you can type in text, drag in some text here, maybe just increase the font a bit, and we can go ahead and have this to be light, anchor it to the top right hand side, and instead of this we can go ahead and set this to be whatever the timer is. So in our game state, every time this happens we have to update it. So what we can do is we can get our player controller here. We don't have a reference to it currently, so get player controller. We have to cast it to our BP player controller, cast to BP player controller. Now we can do this on begin play, and we can store a reference. In a multiplayer game this is not going to work obviously, so promote this to a variable and type in PC ref maybe for player controller ref. We can go ahead and update. Okay, we have a update health function. We can create an update timer function. So custom event, update timer, and this should work as is. So give the timer value to this. So type in timer, get a reference to your HUD, Make sure this is variable, and we'll call this one timer text. Make sure you compile this. So timer text, set text, and we can set this to be whatever this timer reads. Obviously you can use format text and you can make this show minutes, seconds and stuff like that. So we have our timer, so we can do format text. So format text, we can have minutes, colon, seconds. Something like this. So make this in curly braces. And our timer by 60 is going to be our minutes. And our timer mod 60 is going to be seconds. However, we also have one more parameter which we need to take care of, is if this value is less than 10, we want to append a 0 at the start. So rather convert this to a string first. So to string, and once we have the string, we can check if this is actually less than 10, and if it is less than 10, we can use a select instead. So select. So if it is true and if it's false, we need separate things. So if this is going to be greater than 10, which means this is going to be false, so we directly want to print that out. But let's say this is less than 10, we want to append a 0 here. So append, type in 0, and then we want to print the seconds. So some simple logic like this. Now we can go ahead and test this out. And if you were to look at the top right hand corner, it does not update because we have to set the game state as well. So if I just select BP underscore game state over here, and if I go ahead and press play, this should technically work, but it's not. So let's have a look. Under our BP game state, we have our player controller, and we are actually not calling the update function. So update timer. Now this function should work as normal. So the timer is going to be the value which we get over here. And on begin play, we can just set the timer to 0. So we'll just call the update timer function once. If I go ahead and press play, as you can see, our timer works and it increments every second. And if we just give it a little bit of time, so we have a runtime error here, we'll take care of that. So it says assess none trying to read property HUD. This error is in our player controller. The reason is when the game state is actually created, the player controller isn't actually yet created. So that's the reason why, or rather the player controller is created too, but the HUD is not yet created. So once this begin play is called, our HUD is created. So a simple fix for this is to get a validated get. And if it is valid, we are going to set this text and we shouldn't get any errors now. Anyways, as soon as we create this HUD, we can go ahead and update the timer. Update timer. And we can set it to 0. For our timer variable, we can actually set it to some higher value right now, so that we go ahead and test out the minutes part of it. So let's say set this to something like 65. It should start at 1 minute and 5 seconds. So 1 minute and 6 seconds, 7, 8, 9, 10, and our logic works properly. So for stuff like this, you would use the game state. Now the game mode is going to drive the actual logic itself behind your game functionality. But let's say you wanted to access all the players' information. You would do that through the player state class. So I'll just be vague about it. And if you right click in your game state and type get player array, you can actually get an array of player states. So you can actually loop through this in fact. And we can get stuff like the player name. So get player name. And for multiplayer games, you can get the unique net ID. So for these things, basically any details which all players need to have access of at all points of time, those are the things which your player state will hold. So that's about it basically. And one last class that we have left to talk about, which is important, is going to be our game instance. Then we can head into more advanced stuff and we can have an example project created. Unlike all the other classes which we spoke about till now, the game instance is kind of special. The game instance behaves very differently compared to all of these classes. So if I actually just open up my game mode, for example, so we'll open up the main menu, first things first, maps, and our main menu level. And now in my game mode, I'll just go ahead and print stuff. So I'll just print post login and I'll just type in logout maybe. So log out, and we can also have event destroyed, event end play. So we'll just go ahead and print stuff over here as well. So destroyed. I'm just doing this in the game mode, but this could be in any other class. And this is going to be end play. Alright. So if I go ahead and press play right now, and if I go ahead and press play, as you can see, our post login was called. And as soon as I close it, or rather I should switch levels, because if I close the game, the logic isn't really going to be executed. So I'll just type in open main menu level. As you can see, our logout function was called. So what I'm trying to say here is that this game mode class will not persist between levels. So once you log out, this game mode reference, whatever we have, is not going to persist. Now forget about the game mode reference. You can't even access it from anywhere else. So let me actually show you guys using the game instance. The special thing about the game instance is that when you switch levels, your game instance will still remain the same. When you open up the game, an instance of the game instance is created. So basically an object of type game instance is instantiated, and that is going to remain the same. So go to blueprint class, type in game instance, and over here we can name this our game instance or RGI, anything you want. You could put a BP underscore, you can have a C++ class as well, but I don't really find the point in having a base class for this one. Now instead of begin play, you'll actually find events such as event init. So this is when your game actually starts. So if I go ahead and print this out, if I type in init, and if I head into my project settings, type in game instance, I can actually change this to BPRGI. If I press play, and if I press play again, or rather I'll head into the level and do it. If I press play, you would notice that init isn't even printed here in the console, but it was printed way before everything else. That's why it's way down at the bottom over there. The reason is, even before the viewport was properly spawned and even before it started logging stuff, the event init was actually called. So the event init basically refers to when you start the game, not when you open up a level or not when you create something else. Now one thing which I want to show you guys is, I'll head into blueprints, head into our game instance. I'm going to go ahead and call the get game mode function. And I'll go ahead and promote this to a variable, and let's not name it, it's fine. And then what I want to do is, after a while, so let's say I switch from one level to the other. Now I'm going to go from this level to the main menu level. So I'll head into main menu level, and in the level blueprint here, I'll just access the game instance, get game instance. and we can cast it to BPRGI. This can always be a pure cast because it will never fail. And over here get whatever the variable was called. I think it was called new variable 0. And we can go ahead and right click and convert this to a validated get. We can go ahead and print it, and we can say not valid, and this is going to be if it is valid, so valid. So if I go ahead, and I'll actually leave a bit of a delay here. Oops, delay. Let's say about a second, not more than that. So if I go ahead and head into my level again, and if I press play, as you can see, everything works normally. But I'm going to go ahead and type in open main menu level, and as you can see, I get not valid. So what this exactly means is that our game mode object, which was created when we loaded the level, because game mode objects are specific to a given level, as soon as we change the level, our BP game mode object was destroyed, and whatever game mode we had over here in our main menu level, so this is none, so it's just going to take game mode base. So that object was created. However, our game instance was still the same. So if I actually store a reference to the game instance somewhere else, that is still going to be completely valid throughout our game. So anything that is persistent between levels, you would have it set in the game instance. Generally, you would handle save games and stuff like that through the game instance, because even if a player exits a level, your save game logic and stuff should be able to work. And stuff like settings and all, those things are what you would put inside the game instance. Anything related to file handling will also be put in the game instance, and many other things regarding networking in general outside the game is going to be in the game instance. For example, a database, you could handle it through the other classes as well, but this is going to be the safest way, since this class is going to have itself instantiated throughout the program, in our case the game. And even when you actually exit the game, we have event shutdown rather than event destroyed or event end play. So if I just type in print string, and if I just exit, nothing's really going to happen because the viewport is already destroyed by the time the shutdown is called. So stuff like that. Let's say you had to close out some connections or something, you could do that through your event shutdown. Let's say you have a database or something like that. Just give an example. Anything that's persistent between levels, you would use the game instance. And one thing which should be obvious by now, but I wanted to mention, is each player in a multiplayer game will have his own game instance, and you cannot put in-game networking code in this. You can put networking code, but whatever's outside the game. If you have any in-game networking code, there is absolutely no reason to use the game instance. There is no use of calling RPCs through the game instance, since one player's game instance is in no way related to the other player's game instance. So if I actually start two instances of the game, let's say I have two players, even though they may be connected, your game instances will be different. So this player will have a different game instance, unlike the game state or the game mode where it's going to be common for one game. So let's say two players are connected, both of them will have one game mode and game state in common, which will be created on the server. But in a game like this, game instances will not be the same. So I should have done listen server or client. So standalone, in standalone, even game mode, game state and classes like that will be different, because in standalone you are not actually connected. But in any case, your game instances are never associated with each other. So with all the knowledge that you have now, you should be able to create an entirely complete single player game in Unreal Engine 5. Of course, you will need to refer the documentation at times. At times, you will need to mess around with stuff, but this much of knowledge should be enough for you to create a complete game, completely functional game using all of Unreal's core features. However, I am aware that I didn't touch upon particle effects and audio, that is sounds. We will take a look at that when we actually create a practical game. I am not a VFX artist, nor am a sound design person personally. So that's the reason I didn't touch over them. But we will go over some resources which you can use, and I'll just talk about what I do to actually get hands on those resources. Now that's done, we can go ahead and start talking about plugins. Until now, we just implemented plugins which were there in the marketplace. Or if you have a plugin from GitHub or something, you would download it and maybe just paste it inside your project. So if I head in here, you just create a plugins folder and paste that in there. That's simple. But what if you wanted to create your own plugin? If you wanted to do that, and this topic is very less discussed, so not many people actually talk about this stuff. So you're in luck because we are talking about this in detail now. So head into plugins, click on add, and you see many options. Now we won't be worrying about the editor plugins. Those are for more advanced users, and if you're in a state where you're creating editor plugins, I really don't know what is the reason for you to watch this course. So we won't be touching upon this. We'll be looking at third-party libraries later on. We'll be looking at blank content only and blueprint library. Now blueprint library is self-explanatory. It'll just contain a blueprint function library. Let's say you wanted some functions for a vector or something. Maybe you're implementing another data structure for which you want functions. You could have a blueprint library. And content only is basically the type of plugin where you'd have models and stuff like that without any code basically. But the one which we'll be doing is blank. And just give an author name. In my case, I'll give Gamium. And description, this is my first plugin. Well, it's not, but just for the sake of giving a description. And let's call this one test plugin. And go ahead and create it. So the plugin has been created and we have Visual Studio open. However, before we actually start working on it, I want to touch upon one topic, that is the build.cs file. Basically, everything you have in the engine is divided into modules. So the core functionality of the engine is like core UObject and engine. So now that you have actually created your plugin as well will have a build.cs file. If I actually open the folder over there, so plugins, test plugin, and if I head into source, test plugin, I have a build.cs file here, and I have content, binary, stuff like that. So what this basically is this plugin itself is actually a module in itself. So if I want to use this plugin in C++, let's say, I should go ahead and include that module. So I can do that by typing in a comma, and we can type in test plugin. This concept will be more clear once we actually implement a third-party library. When we implement a third-party library, you actually have a separate module for the library as well as your plugin as a whole. Basically, your plugin acts as a wrapper so that it can interface with Unreal Engine, because Unreal standard API does differ a little bit compared to your standard C++, what you do generally. So you'd use the plugin as sort of a wrapper to, interconvert types. So let's say you wanted to convert all the std strings into f strings, which is there in Unreal. So stuff like that. So you'd have the plugin as a wrapper and you'd interface that through the plugin inside the engine. So let's actually take a look at our plugin now that we have a basic idea of build.cs. In our editor, we already have our test plugin content folder open. We can work with this normally, but anything we created inside here will be actually packaged inside our plugin. So for example, let's create an actor class. So let's just call it some actor. And whoops. and we can make it do something, let's say. So for example, let's say we have some logic. So let's say every frame it just prints out something. Obviously you would have some more practical logic in here. So let me go ahead and type something. So let's say our actor is ticking, something like that. And we could go ahead and have C++ classes as well. So over here under tools, you can create new C++ class. I'm just showing you guys how to do it because we did go over the blueprint itself. So you know how to work with blueprint. It's just that you're creating it inside this directory, and I'll show you guys how to reuse it in another project. So head into tools, new C++ class, just like how you would. Let's say you wanted to create an interface. So I just took an example, and instead of my interface, we can call this one our plugin interface. And instead of beginner course, you can type in test plugin because this is a separate module in itself. And now if I go ahead and create the class, you'd see that under our source, or rather under our plugins folder, so I'll just reload the solution. Under our plugins folder, under the source folder, now you should be able to see our interface. So now you can work with this just like how you would with another file. So this is how you would actually go about doing it. So now if I just go ahead and close this, and rather I'll just close the editor. And remember guys, make sure your plugin is enabled here. If you are not able to see it in the editor, make sure you enable this. So what you can do is, first of all, let's see if it actually builds successfully. So we'll just create a U function. So it's going to be a virtual function because we want to override it. So virtual void test function, and we can go ahead and leave it as is. We don't really require a default implementation, but we'll have one anyways. So right click, quick actions, and create a default implementation. And now we should be able to implement this interface. So let's make this a U function. So U function, U function. And just to make our job a little bit easier, we'll just make it a blueprint implementable event, so that we can actually just give the logic in blueprint itself. So this works. And now if I just go ahead and build this, you should see that both this plugin as well as our whole project will be actually built. So it says blueprint implementable events in interfaces must not be declared virtual. Let's just fix that. And now it should build as is. Just make sure you don't have a definition here because it will look for the definition in blueprint. Now let's say I wanted to use this in another project. This is how you would go about doing this. So open up your editor, head into the plugin section again, and where you have your plugin over here under project other, click on package, just select a random folder. I'll just select my documents for example, and go ahead and package the plugin. It will take a little bit of time, but once that's done, you should be able to implement that in another project. So meanwhile, while this is actually compiling, we can go ahead and create another project. So open up your Epic Games launcher. So our packaging is actually complete before the launcher loaded up. So you can actually check it in our documents folder. So head into test plugin, and you should be able to use this in your projects. And I'll show you guys how to do that. So just ignore that, head into library. Let's actually just launch the engine as is. And over here we can go ahead and just create a new project. So we'll just create a blank project, blank with nothing. I'll just create blueprint, and for the project name, okay, we do have a C++ class, so it might actually want to rebuild stuff once again. So anyways, what we'll do is we can create a C++ project, call this one plugin test, and we can go ahead and create it. So I'll show you guys how to implement it both in Blueprint and C++. Anyways, now that we are actually in the process of creating it. So it should take a while, but eventually once the project is opened up, we should be able to import the plugin just like that, and I'll show you guys what steps you need to take in order to actually get this in the plugins list. Now our project has been created, so we are in a blank level. We'll just go ahead and create a new map, and let's just call this one some level. Open it up, save it, and make this the default. Project settings, maps and modes, make this the default. So that should be good. And if you open up your Visual Studio, which we will open later, we'll close this up and close the editor as well. And beginner course, will just minimize that for now. If I head into my file explorer, what I can do is I can copy this over, and where I have my other project, so I believe I created it under Unreal project, so plugin test. And what you want to do is you want to create a new folder called plugins and paste this over there. Now what I want you guys to do is right click, generate Visual Studio project files. So this is actually going to integrate it, and once you're done with that, if you want to use the plugin content in C++, all you have to do is head into source, plugin test, and under plugin test build.cs. We don't actually need to come here. Actually, this is for the plugin. What's the plugin using? So what you have to do is head into your plugin test, the project, head into source, plugin test, build.cs, and over here, so I meant to come here. So over here, what I want you guys to do is where we have our modules, I want you guys to add test plugin. Just don't get confused. Plugin test is our Unreal project name and test plugin is our plugin name. And now I'll show you guys how to implement it. So we can go ahead and build this once again. So we'll close everything up and we'll just generate the Visual Studio project files once again. And we'll close our beginner course. We'll open it up and we'll just create one C++ class and maybe a blueprint class. So we'll do blueprint first since we are opening the editor anyways. So we have some level, and if we actually go ahead and create something, so let me just create an actor. If I head into all classes and if I type in, so I'm not sure what I called it, so we can head into plugins and check test plugin content some actor. So some actor, as you can see, we get some actor. Now if you're not getting this, it simply means that you haven't enabled it in your plugins. So under installed other, you should have test plugin and you should have your author name and stuff like that. So make sure you have this enabled over here. And now if I go ahead and drag this in the world and if I press play, as you can see, our code which we had in our actor is now working in the other project. Similarly, we can use the interface as well. So over here under class settings, implemented interfaces, we can go ahead and look for our interface. I think we called it our plugin interface. And we have our test function which we can implement, and we can go ahead and tell something. So you could just say test function called. In order to implement this, however, we would require C++ since we actually didn't make this blueprint callable. However, we can still choose to edit it in the source over there. So if I just head into our source and if I actually go ahead and edit the CPP file, we can actually in the plugins folder, test plugin, if I head into the source folder and edit the CPP file, or rather the .h file, and add the blueprint callable specifier, I would still be able to use this over here. But anyways, we will implement it in some class which we create here. So I'll just go ahead and close Visual Studio here, and I'll go ahead and create something. So we can create a new C++ class of type actor. We are able to implement this, but we can't call it. That's the reason we are actually doing it. So we'll just call it my actor for now and go ahead and create it. So live coding should do its thing. So our file should in fact open up in a new window right now, and go ahead and just don't mind it opened up in a separate window. And now we can feel free to go ahead and include our interface. Just gone ahead and reopened the solution file here. And now inside myactor.h, since we included the module in the build.cs file, we should simply be able to include our plugin interface.h. Now you should be simply able to inherit the interface by using public our plugin interface, and now we have successfully inherited the interface. Now since this was a blueprint implementable event, you can just go ahead and use it in blueprint itself. And just to make things a bit convenient for us, we can head into our plugin interface.h file under the plugins folder, and we can add in the blueprint callable flag. So now we can go ahead and actually call it from the blueprint. So we can go ahead and run a debugger now. So this is how you implement it in C++. My main intention here was to show how to include the header file rather than using the interface. That is something which we already covered. So wait for the editor to load. And once the editor is loaded in, what we can do is we can go ahead and create a new blueprint class, and we can remove this actor first of all, otherwise it'll keep printing our actor is sticking. So go ahead, select actor, we'll leave this at new blueprint 1, add this, and under the parent class, or we could have done it over there itself, we'll select my actor, and now again we have our test function, and we can again go ahead and implement our event. So we can go ahead and print something, let's say test function called. Or we could have gone ahead and inherited my actor instead of some actor here. But then again you would have to change some other stuff. So we'll just redo this. And now if I go ahead and press play, nothing's gonna happen. Head into your level blueprint, and for example, just go ahead and get a reference to it. And now if I just call in test function message, this is what we want. And now if I go ahead and press play, you see we get test function called. So this is basically how you do it, guys. So this is basically how you would use a plugin which you made and implement it in another project. And as you guys saw, you can absolutely feel free to edit the plugin contents once you have pasted it in this plugin folder. Now let's move on to third-party libraries. Now there is one thing to understand before we actually head into implementing them, and that is that there are differences between your standard C++ API and the Unreal C++ API. A very simple example would be the difference between std string and fstring. So in Unreal you'd use fstring, whereas in standard C++ you would generally use std string. Now interconverting between them is really easy. So if you want to implement a third-party library, the way you would do it is you would build your third-party library inside of a plugin. So basically you would put it in a separate folder, and I will show you guys the procedure, so nothing to worry about that. And the Unreal plugin which you will create will act as a wrapper to kind of, interface between the standard C++ and Unreal C++ API. So the way you do it is, again, create a new plugin first. Select this third-party library template because it has most of the important things that you would need in order to actually set it up. So again, I'll just put Gamium for the author, and I'll just call it some third-party library plugin And over here we can just call this one TPL underscore plugin or something like that. So third party library plugin. So go ahead and create it. So now this dialog box should appear over here, or rather message box, and we'll just click open or OK. So basically that was just some code which was written in the example library. Now over here we shall not be using their library. So they have actually provided us with a library which we can use as a reference. So if I head into plugins, TPL plugin, source, you see there are two folders here. Now third party is the folder where you'll have your third party library, and TPL plugin is the folder where you would have your plugin content. And anything under this folder would be edited in your project solution file, and I'll show you guys what I mean. So right now head into third party plugin library. So what we can do is over here, as you can see, there is an example library. Now whichever file says example library dot something, that is basically your actual third party library. So in order to implement our own third party library, we can go ahead and delete whatever they have put over here. So we don't need any of this. So this is just an example, and what they have done is they've used a DLL, but I'll be showing you guys how to implement a static library and a DLL separately. So we'll do a static one first. So I'll just go ahead and delete all of this. Now what we are left with is a blank folder with just the build.cs file. So what you want to do now is open up Visual Studio, and over here you can go ahead and create a new project of type static library and click next, and we'll just call this, I don't know, test third party library or something. So test third party library. So we'll create it under a G repositories, or rather we'll just select our solution folder. So we'll go ahead and select our beginner course, head into the plugins folder, TPL plugin, source, third party TPL plugin library, select this folder, and what we can do here is we can check place solution and project in the same directory. So we would have all those project files as they appeared in the example. So go ahead and press create. Now you should see that our library is actually created. So if I go ahead and open up this folder over here, as you see, this folder has been created. It's not necessary that you have it over here. So you can just go ahead, cut this and paste this over here, and you can go ahead and delete this folder. So it's open in Visual Studio. So I'll just close everything. So I'll just save it. So we can just cut this and paste it over here. So we shouldn't have opened that. So we'll just replace it as of now. Nothing should happen. Now once we're done with this, we can open up our build.cs file. And over here you would notice that we have a bunch of stuff which I seriously don't expect you to understand. Basically these are for Linux and Mac, so you can just go ahead and delete these. I'm not going to be showing how to work with .so files and stuff, so I'm not really a Linux guy, so we'll just be working with our Windows library. So we'll not do the DLL now, so I'll just comment this out. We'll do the DLL a bit later. And what this is basically your library directory and the library file itself. Now example library.lib was the file which they had created. So whatever example library they had, that file was named example library.lib, but ours isn't yet here. So we can just go ahead and add in some sample code so that we can actually create it. So head in here, change the configuration to release first things first, and head into source files, add a new item, and over here you can go ahead and create a .h file because we will need some sort of a header to include it. So we can just type in test class. We'll just create a class. So test class.h. Maybe you can create some static method inside. And over here, we can actually move this over to the header file section. Right click on source file, add new item, head of source cpp file, and we can call this one test class.cpp. And once both of these files are open, over here we can just start writing a class. So we can call this test class, and under the public section we can simply have a method. So under public, and under private we can have a string variable. So std string, and we need to include string obviously, so hash include string. So we have our std string. We'll just create a variable called maybe test string, and we can write a constructor here to just initialize it. So what we can do is we can go ahead and create a test class and write the definition for the constructor. The reason I'm not doing it in line over here is because I want to show you guys that the lib file is actually doing something. So if we have the definition right here, so we wouldn't really need the library file. Now I can go ahead and create the definition for it. And what we can do now is under this, we can go ahead and just initialize our string. So we can say test string equals, this is some test string. Doesn't really matter what you put in there. And we can just have a method. So we can have std string get name maybe. Now this is going to return that string basically. So we can go ahead and test that. So we can go ahead and return test string. Now this should be about it for this. So before you go ahead and build it, just set up this pch.h file and stuff. So go ahead over here, instead of test class.h, just include this pch.h. And what you'd want to do is you'd want to come here and just include your test class.h over here. So now this should compile. So if I go ahead and press build, make sure it's in release configuration, and it should work. So now if you were to head into your TPL plugin library folder, now under this x64 folder which has been created, you should find your .lib file. Don't worry about all these other files, just go ahead and copy this file name, which will be the same as your library file's name, your library's name. So test third party library.lib, that is the file which we want to include. So now that we are done with this, now we should in theory be able to wrap this using our TPL plugin. Now this is actually the code for our Unreal plugin. Now inside this, we'll actually be writing some code in order to just wrap this class, whatever we wrote over there. So go ahead and head into your beginner course solution. That is your main project solution. And now if you head into your test plugin, or rather the one which you created now, so TPL plugin, source, TPL plugin, and we should be able to actually work with this. So we'll just do it inside this header file. As I showed you for the previous plugin, if you want to add in more files and stuff, you can do it through the project, or we can actually do that actually since we have our solution open anyways, our Unreal project. So over here we can go ahead into tools, add a new C++ class. We don't really require an actor, so we'll create an object. So object, create it, and we'll call this one wrapper object. And this will just be under my TPL plugin. So we can close our solution since it will open it up once again and create the class. Now, if you were to open up your solution, you should see a wrapper object.cpp and stuff. And one more thing, this is something which you really don't need. So now you can just feel free to head into this function here and just delete all this code. And over here as well, you can go ahead and just delete this. Make sure you just have the functions. And for this one, basically we don't have our example library.h. We instead have our test class.h. So this will work. We don't need it here, so we aren't going to use it. So you can just leave the rest of it as is. And now if we were to continue now, but now if I were to go ahead and build this, so if I just go ahead and hit build, now wait for it, and now you would notice you actually get errors even though you didn't have any code. The reason is, well, we don't actually have our uObject module. If you get any errors like this, cannot open include file, and it's something like this, basically it's the same thing. You haven't included the module. So what you have to do is head into your TPL plugin. Under source, you should find your TPL plugin build.cs file, and if you were to recall your main build.cs file, that is your projects build.cs file. So if I head into source, beginner course build.cs, you see there is a module known as core uObject, and this isn't there in the TPL plugin build.cs. So just go ahead and include that, and now it should build successfully. So if I just click on build, now this should build with absolutely no problems. So now we can go about implementing a wrapper object. Basically we are trying to get our test class to work with our actual code here. So I'll just do it under the public section. So whenever this uObject, that is uWrapper object, will be instantiated, I want our actual third-party library object to be instantiated as well. So we can go ahead and type in test class obj equals, we had a default constructor, so we'll just call that. And the reason we get errors is because we haven't included the header, so we can get TPL plugin library, so library, and we call it test class.h. Now we shouldn't get that error. Now we should be able to create our object. And now we can go about writing our functions for it. So the only difference in the main with the standard C++ API and Unreal's API in our example is that we used std string over there, but we want to use f string. So we can write a u function for it. So u function, we can just call it get name, and the return type is going to be f string, of course. And we can create a definition for it. Create a definition, open it up, and inside the f string constructor we can get our object obj.getName.cstr. So cstr. So this is how we can just convert it. Now this is something related to the conversion. You can just look into the documentation or the forum. So this is how we would go about converting it, and we'll make this one blueprint callable as well, just so that we can test it in blueprint. And now successfully we have translated our standard C++ function in our third-party library, and this is now usable in Unreal. So if I just go ahead and run a debugger here, inside our project now we can ignore this and we can head into content, and we'll just do it under blueprints. Go ahead, create a new blueprint class, and this will be of type wrapper object. So we don't find it, and we forgot to make this blueprintable once again. No issues. We can make this blueprintable, and you can make it blueprint type as well if you wish. So we can go ahead and restart the editor now. And now under content, blueprints, if I right click, create a blueprint class and type in wrapper object, we should get our wrapper object. And we can go ahead and just call it bp_wrapper. So this is our wrapper class basically. Now if I were to, actually go ahead and call the function, we can actually do that. So we'll instantiate the object and call it. So our function was called getName. Oops, getName. Call function getName. Target is wrapper object, and we get a string. So we can go ahead and test this method out. So in our level blueprint, we'll just construct an object. So we can ignore this. We can go ahead and construct object from class, and we can construct our wrapper object. So BP wrapper. We didn't really need it, to be honest, but anyways, we can go ahead and call the function getName once it's successfully constructed, and we can print strings so that we can check if it works. So now if I go ahead and press play, as you would see, I get this is some test string. And this is exactly what we put in our third party library. So if I head into third party, test class.cpp, as you can see, we had our std string and we actually called this method through our wrapper class. So this is basically how you implement a third party static library. So now let's get to DLLs. Now working with DLLs is going to be a little more tedious, and if you were to take my opinion, in Unreal Engine at least, it's really not worth the hassle to work with DLLs. I always prefer just working with static libraries or any Unreal native plugins. But anyways, I'll just show you guys with the example itself. The procedure is the same. Head into plugins, click on add third party library, and we'll just call this Gamium, and plugin name, let's just call it DLL test. So we're going to create the plugin and it should take us into Visual Studio. So we get this message box here, so which is from the functions given in the DLL. So just head into your Solution Explorer and under your plugins, you should find your DLL test plugin. And if you open up your third party folder, you should be able to see the code. Now we'll just be modifying it in here. So we'll just call a function. So example library function, let's just head into the definition. They're just creating a message box. Similarly, we could just have our own function. The important bit over here is the export part. So basically you have this macro which is going to export the function. Now the usage of classes isn't really covered here, so I'm just going to do that instead of writing my own function. Obviously you can implement the same thing with your own DLL. But remember the changes to the build.cs files which you have to make. So under plugins, DLL test, source, DLL test, or rather third party, DLL test library. And in this build.cs file, again you will probably have to change a few parts. You can remove this if you're working on your Windows. So this is over here, just change the file name to whatever your DLL is, and over here for the lib file as well, just make sure you change it to whatever your file name is. Even here as well, just do those changes and you should be good to go. And the addition of modules will still remain the same, so you will still have to include core U object and stuff. We'll do that, so not to worry. So if you want to actually export a class, you would have to do it right here in the .h file. You can have the definition separately in the CPP file, but I'll show you guys how to actually do it. So the way you do it for classes is a bit different. For functions, you can follow this example and move on. But over here, let's say I want a class, so I can do example library export. Now I am assuming we are developing for Windows, so I'll just go ahead and delete all these elifs. So I won't be having any of that, so I'll only have the macro declared, even over here as well. So I'll just go ahead and remove all of this, and I'm just assuming that everything is for Windows. So with that assumption, let's continue. Now if you want a class, we can go ahead and declare it. And one more thing, in your .h file as well, make sure you just have this macro. If you want to work with class, if you're working only with functions, you don't really require. So now what you want to do is, let's just call this one test class. And over here we can go ahead and have some methods. So let's say int get num or something, and we can have a variable as well. So under private we can have int num, and for this we can go ahead and provide a definition for it. And one more thing, for each definitions, so for your class definition here, make sure you put in export. For methods you would put in import here and export in the definition, but since your class definition is here itself, make sure you have example library export or whatever your library name is, and we can just go ahead and return num. So what we can do is we can write we can just set this to some value. What we can do here is we can write a constructor actually. So this class is called test class, and we'll just write it in line over here. What we can do is num equals, can grab in a random number between 0 and 99. So this should work as expected, and then our get num function should work as well. Now once you're done with this, our DLL's example library should work. So what we can do is we can go ahead and, before building actually, we can create a new file. So head into your editor and we can close the solution for now. We can build it and close it. So we have live coding enabled, just ignore that. So build it. So this should build successfully. Now if I just head back into my project, beginner course, and if I head into my uProject file here, once it loads up, you would see the message box as is. If you don't want that, I'll just show you guys how to disable that. If you don't want the message box, head into your DLL test, third party library or whatever, or rather source DLL test private DLL test.cpp. This is the file where it's actually given the function definition. So just go ahead, open that and edit the file to remove the function definition. So let it open up, and over here what you would want to do is you would want to remove this function definition. So you can remove this and then the message box isn't going to pop up. You can remove this as well, but that's not going to be called unless it fails, so not to worry. And even this path as well, so if you do require to change it, you will have to change it. If you're implementing your own, make sure you account for all of these. So heading back, go to tools, new C++ class, all classes, object. We'll go ahead and just, or we can do actor just to keep things a little more interesting. So we can go ahead and create an actor, click on next, my actor, make it under DLL test, and we can go ahead and create the class. So this should open up our solution file, and don't mind if live coding fails, we'll just close and reopen that, not to worry. We can go ahead and open the solution file once again. So we'll go ahead and close this. And once the solution is open, we should be able to go ahead and find our file here. So under DLL test, private DLL test.cpp, or rather myactor.cpp, and we should find all our function definitions. And not to worry if you get so many errors, it's just to do with the build.cs file once again. It's kinda dumb, but it's something which you have to deal with. So over here, make sure you include engine and make sure you include core U object. Make sure you have these two modules. If you want to access Kismet and stuff like that, you'll need engine. If you want to access your U object type, you'll need core U object. So If you don't have an idea of what contains what, you can go ahead and have a look at the engine module in the documentation. Everything is given over there. Otherwise, you could just follow along. So head into, now it will build. IntelliSense isn't refreshed yet. So head into your myactor.h and we can go ahead and include a header. So you can go hash include dll underscore test library, and our header is called example library.h. Of course, if you have your own header, that's going to replace this. And we shouldn't get any sort of errors here. And over here we can just write a function. We'll just do it inline. So u function, make this one blueprint callable to make things simple. So blueprint callable, and we can call this one void run dll function. So I'm not really bothered about the name too much. And now what I can do is I can go ahead and write a definition for it. We'll just do it over here. So from our DLL, we can go ahead and grab it. So the function which we had was called getNum. So we can go ahead and instantiate an object to that class. So our class was called test class. We'll just call it obj. And we can go ahead and call the function. So we'll do it in the next line. And obj.getNum. We can go ahead and print this by typing in ukismet system library print string, and we can just pass in a this pointer, and we can do f string. So it's an integer, so from int, and this should be good to go. Now what we can do is we can include kismet because we don't have the print string function here. So hash include kismet system library.h. Now this should build successfully, assuming we haven't made any mistakes here. Now it's giving us an error. It says test class type redefinition. A simple fix would be just to do pragma once. So pragma once, and this should build now with no problems. Now we can go ahead and open up the editor. So once we open it up, we won't get the message box now because we had disabled that. And over here, if we just head into a level blueprint, for example, and make sure under the play mode, just change this to standalone because we had it set to multiply, we can go ahead and construct an object from class, or rather we can do spawn actor since it's an actor. So my actor is what it was called, and we can just have a default transform. It doesn't really have anything. And from this we can go ahead, and I'm not sure what the function was called. So let me just have a look. So our function in my actor was called run DLL function. So we can go ahead and call that. So run DLL function. So in theory, we should get stuff printed over here, but this will probably not work now because we haven't actually compiled our library itself, which is kind of stupid. So head into DLL test. So third party DLL test library, example library.solution. Now just click OK. And now what you would want to do over here is go ahead and select your release configuration and go ahead and build it. Oh, and yeah, make sure you close the editor when doing it. That was the error which we got right there. Now if you were to go ahead and open up your beginner course U project, once that's loaded in, now we should be able to call the function and it should work as expected. So in your level blueprint where you called it, run DLL function, and we can go ahead and click on selected viewport, and as you can see we got 95. If I go ahead and play, we get 66, and we keep getting random numbers every time. So our DLL actually worked. But if you do want to implement your own, it is going to be a little more complicated than this. Even with just including the one which was provided to us with Unreal, it was a big hassle. So make sure you guys avoid using DLLs I prefer using static libraries, or I restrict myself to those for Unreal at least. So that's it, I guess, about third-party libraries. We can go ahead and talk about multiplayer now. It's going to get fun, guys. Now let's talk about networking in Unreal Engine. So networking basically in Unreal revolves around star topology, basically your server client model. So basically you have one player or a dedicated machine which acts as a host, which we call the server, and you have all the other players which are clients. Now there are two types of servers in Unreal Engine. One is a listen server and another one is a dedicated server. In a listen server, the server itself acts as a client as well as the server, that is the host. Whereas in a dedicated server, the server only acts as a host and does not have a player controller. So these are the two types of servers, and basically any data that has to be passed through a network, as you can see in this diagram here, there is no connection, there is no direct connection between two clients. Always, if data has to be passed from client 1 to client 2 or vice versa, it has to be routed through the server. So that is one thing to note when it comes to networking in Unreal Engine. Now, there are many questions which might arise regarding the efficiency of this and stuff, but most games these days work based on this principle, and it is in fact very robustly implemented, and we will be talking about all the features of Unreal networking soon. I've brought up my main menu level here, and I just want to demonstrate how you're going to join two standalone games, that is two games on separate computers, into one. So if you aren't familiar, net mode will basically let you choose between the types of servers which I talked about. Play as client is your dedicated server basically, and play as listen server is going to be a server which is also a player along with the other clients. Play standalone will basically mean two separate games, and that's what we will be doing. Now what if you wanted to connect between these two? So we'll be using the game instance for it. So open up your BP game instance. Now I am recording this a little bit later, so that's the reason you may see a few things which you haven't seen. So BP RGI, and we can just set up a couple of custom events. We'll first of all delete all of these. We don't need these. So I'm not sure, we may have broken some reference, doesn't matter, so we'll just go ahead and fix that. So we'll just delete that, and now if I head into RGI and I'll create a custom event. Now basically connecting to a single game is handled by something known as a session. So every time your players are connected, Unreal actually has something known as a session stored internally. We aren't going to be diving into the C++ part of this. We'll just be doing this in Blueprint. But please note that if you want finer control over these properties, you would want to work with C++. So session is basically what is going to allow your players to connect. So let's go ahead and create a session. So what we can do is we can do something like create lobby would be inappropriate. I'll just call this one create session, and we'll go ahead and type in create session. And as you see, there is an async task over here. And if you guys aren't familiar with this clock symbol and a node like this, this is an async task. And public connections, we'll just set that to 2 for example. So 2 players. And player controller, this is for listen servers. If you have a dedicated server, you don't have to pass in the player controller, but in our case we are passing it in. So we are going to use the function get player controller, and then use LAN is set to false. You could do it if you wish, and upon success what you can do is you can go ahead and load a level. So open level, and we can go ahead and open our beginner course level. Alright, and then what we can do is we can go ahead and create a function to join session, or I would call this one create match so that it sounds a little more familiar. Join match, So what we can do is we can first of all find sessions. So type in find sessions. These are the only few functions which are there in this library, so that's the reason I'm not really going over them that much. So we can get the player controller, and what we can do is max results. You can just set it to something like 100, and we are going to check if it's a failure or if it's a success. So what we can do is first of all we can get the length. So if it's a failure, we're just going to print something. So we could say failed to join a match. And what we can do is we can get the length, and if it is greater than 0, we'll go ahead and just join the first session. Obviously you can have your own logic here. So each session is going to be one hosted game basically. So let's say there are three members in this array, or three elements in this array. What it basically means is there are 3 people hosting a match right now. That's what it means. So now what I can do is I can grab the results and I can get a copy of the first one if the length is greater than 0, and I can go ahead and type in join session. Alright, and here we'll again need to pass in the player controller. And note that you can only run these session functions either on the player controller or in the game instance. You cannot run them on other blueprints. It is simply going to fail. Now once that's done, let's say we have no sessions, we can go ahead and create a match. So create match, and on success we don't need to do anything. Engine will handle it for us. Over here you can have something like a progress bar or something. Until on success is called, you could probably have some throbber or something like that to show that it's loading. Same over here. So this should be good. And something very simple which you could do is inside the main menu. So on clicked, what I can do is instead of opening it, I can grab a reference to my game instance. So I can type in get game instance, which is a static function, and I can cast it to bprgi. This will always succeed. I'll just cast it over here. I'm not going to bother storing a reference to it as of now. And I can go ahead and, or actually I'll just do it the right way. So I'll just call this one main GI. You could call it anything. It's just a reference to our game instance. And once we have that, we can go ahead and use it, and we can go ahead and join match. So join match. Now that that's done, if I go ahead and press play, here, as you can see, nothing is really happening. But after a while, we go ahead and join this session. Basically, we load up the map. Now that we have actually created a session, and if I press play on the other game here, and if I just wait for a while, so you would want to disable the input during this time, but anyways, for now we'll just not do anything. You would see that you actually don't join the session. The reason is you actually need to be listening for incoming connections in order to actually be able to join the game, and I'll show you guys how to do that. Over here where you have open level, make sure you just put in listen under the options. So make sure you do that before you actually do it. And one more thing, plain editor is crashing my game for some reason. So I'm just going to go ahead and I'm going to run this standalone. So standalone game and standalone. So play standalone, and I'll play this as a standalone game. So I'm not really sure why the issue is happening, but this is one way I can test it. So if I press play on one of them, and if I go ahead and wait, so we should land inside a session. As expected, we are in the level and we are able to do stuff. Now I'll just go ahead and click on play here. In theory, if everything is set, we should in theory land in the same map. So as you can see, post login was called on the server, and if I were to notice, my client has successfully connected over here. So as you can see, I'm able to play the game like this. So this is basically how you connect to clients. Now let's actually talk about how to set up stuff in multiplayer, guys. Okay then, so if we want to work with multiplayer, what we can go ahead and do is we'll start with a new level, because if I go ahead and press play with 2 players here, and if I actually close the game, you see we'll get a few runtime errors. Now this is mostly because our code isn't really set up for multiplayer, and you will soon understand why. So basically now what I want you guys to do is head into your maps folder, create a new level, and we'll call this one multiplayer testing. So go ahead and open it up. So this should be a blank level. So I'll just grab in a sky and grab in a directional light here, and we should have everything set up. And maybe if we want, we could have fog, and we can just create a simple landscape. So head into your mode selection, landscape, and we can go ahead and create it. So I'll just do a little bit of noise so that we have a starting point, so that we have some sort of a workable landscape. So increase the brush size. So the strength is a little too much. 0.05 should be fine. So let me just go back. Okay, that should be good for us. Now what we can do is we can go ahead and talk about multiplayer. So the main aspects of multiplayer in Unreal are replication and remote procedural calls. If you are clear with how to use these two concepts, it's pretty simple to code a multiplayer game in Unreal Engine. It's much more difficult to do it with general knowledge of networking, but with Unreal's framework, it's really very simple to set up multiplayer. We'll discuss both Blueprint and C++ aspects, but first the basics. Now I want you guys to head into Blueprints, and under here I want you guys to just select your character and your BPA. So I guess this one is where we had physics enabled. So if we do, yep, we have physics enabled. So I want you guys to just show the problem with just running multiplayer in general. So I'll just go ahead and drag this in, and what I can do now is I can go ahead and grab a few player starts here. So I'll grab one here, grab another here, and make sure they're all facing the same direction. So what I can do is I can make this one 90. So they're all facing towards this ball right there. And now what I'm going to do is I'm going to change the world settings to use our BP game mode. And for the player controller, we can ignore that. We'll still get the runtime errors. So what we can do is we can remove this logic. So we'll forget about the HUD for now. And if I go ahead and press play, now you see the ball has fallen down and it's rolling down the hill over there. And as you can see, I kicked the ball. But if you were to notice, the ball is in a completely different position. So the ball is over there for me. And if I actually head near the ball here, you'll see that I'm not actually going near the ball on my other screen. So if I actually turn around, my character is somewhere there and my ball is somewhere over there. So as you can see, both of these are not in sync. Now this is something related to the widget, nothing much to worry about. So basically what I'm trying to say is that these two games which are running on separate windows are not in sync. But you'd notice one thing, that your characters are in sync. So for example, if I go ahead and run forward, and if I go ahead and run forward over there, and if I actually look up, you'd see that my characters are in sync. It's just that the physics object over there is not in sync. So the reason this is happening is because in our character, if you head into your class defaults and head into the replication tab, you see that these two flags called replicate movement and replicates are enabled. Basically, this is Unreal's way of telling us that, or rather asking us, whether we want this particular class to be in sync with all players when instantiated. So let's say we instantiate a BP character, it will always be in sync. Obviously, there are conditions you have to instantiate it on the server. We'll talk about servers and clients soon. So let's head into our actor and try to fix it. So head into your class defaults and let's try enabling replicate movement and replicates. If I compile and if I go ahead and press play, as you can see, now the ball's rolling down, it's near me, and as you can see, this seems to be in sync. If I go ahead and block this, as you can see, this is almost completely in sync. Now, one of my characters flying is due to the movement mode, just ignore that. But as far as I can see, everything is in sync. So this is basically how you get stuff to go in sync in a network game in Unreal. This is the most basic aspect of it. You might see that there are a few more flags here, such as always relevant, call pre-replication, net load on client. Most of these aren't really important. We'll just talk a little bit about net cull distance squared and net dormancy and stuff. But most of the times, 9 out of 10 times, you'll only mess with replicates and replicate movement. Sometimes you may need your actor to be always relevant. Let's say it's something important to your gameplay. You will have always relevant enabled. So once that's said, let's also talk about net priority. Basically, the higher the value, the more priority is given for this to be updated. So let's say you have thousands of actors and your bandwidth is insufficient to actually update all the actors. The ones with higher priorities will be updated first, basically. So now that we know the basics of replication, let's start syncing up some variables. So if I head into my actor and if I go ahead and create a variable, so we have some float already. And what we'll do is on begin play, we'll go ahead and set this to some random value. So we'll get random, so random float. And what we can also do is we can go ahead and print this string. Alright. So let's look at what happens. So let's actually delete some of our other methods here. So I guess we had some stuff in our character. So we'll just stop calling this function and we'll ignore this spawn actor. And I'm not sure if anything else is printing something, so we'll ignore the left mouse button as well. Now if I press play, as you can see, we only get our post login and we have 0.809 and we have 0.43. Now clearly this is not what you want. You want them to be in sync. So if you want variables to be in sync, the first thing you'd want to do is you'd want to set this replication tab to replicate it. Now let's go ahead and try that actually. So if I press play, we still get different values. The reason is, even though we set the value, we need to set it on the server and we also need to wait for the replication cycle to take place. Basically, your value doesn't immediately get replicated. Instead, your value gets replicated in the next replication cycle. So every once in a while. So in our case, if you head into class defaults, you see this net update frequency parameter. It's set to 100. Let's say we set it to something like 10. Now this variable will be updated after approximately 0.1 seconds. Obviously it can be less than that, but up to 0.1 seconds. If I make it 100, it's going to be up to 0.01 seconds. So it's not instantaneous. Remember that these two players, what we play here, they are not running on the same machine. So you cannot expect the variable to update immediately. So what we can do is we can actually set some logic to update this. The principle which actually goes into this is the fact that all your replicated variables need to be set on the server. So let's go ahead and do that. Now just a quick note here, the event begin play which is there, since this actor is replicated each time one computer out of all the players will spawn the actor. So for each computer this begin play will be called. So if you didn't get what I mean, if I actually simply go ahead and print a string, so if I go ahead and type in print, and if I print hello and if I press play, you would notice that the server and the client print hello. What that basically means is as soon as the client logged in, that is when the client entered the game, this actor was spawned on the client and begin play was called both on the server as well as the client. So what we can do is we can check if we are on the server. So we can type in is server and we can do a simple if check. If we are the server, we can go ahead and set this value. So we can go ahead and do that. And if we are not the server, we can go ahead and print it. So one more thing we can do is, okay, this is gonna work. Let's just do it. So we can go ahead and print some float and go ahead and press play. As you can see, the values are the same. In case you guys have any doubts regarding that, you can go ahead and plug this in directly like this. If I press play, you see 0.718, the value is the same. So basically all your replicated variables need to be set on the server. That's the first thing. Now what if you wanted a client to set the value? So your client cannot actually set the value. However, oh, and just another thing, this logic is going to work for 3 players as well. So if I go ahead and do this for 3 players, so as you can see, all 3 players have the same value initialized, so that's going to work as well. Okay, anyways, getting back. So let's say now instead of this, we wanted a client to actually set the value for us for all the players. So the way you do that is through a remote procedural call. So replicating variables, this is about it. There's really nothing much to it. So this is basically how you'd replicate variables. I will get to rep notify. So let's say you wanted to call a function when a variable has been replicated. Instead of replicated, you can check this rep notify option. So then what's going to happen is when the value of the variable is set, this function will actually be called on all the clients. So if I go ahead and play, you'd see we get a hello as well along with that. So we can just type in rep notify. So we get whatever string we put over there. So basically, that basically shows that our replication logic is working. That's pretty much it. We can have any other functionality. For example, let's say you have rep notify on a health variable, you can update the health bar. So something simple like that. Now, let's go ahead and run this logic from the client. So let's say we set this on the client and we already saw that that does not really work that well. So what you have to do is you have to use a concept known as remote procedural calls. Basically, they're just custom events meant for multiplayer in Blueprint. So type in custom event and we'll call this one set some float. Some float is the variable name, so we just made a setter for it. Under this replicates tab, set this to run on server. Now what this is going to do is this is going to ensure that this runs on the server. So if you call this from an owning client, now we will get to the problem with it. And if we run it from an owning client, we are going to be able to call this on the server. So reliable basically means you want it to run in order. So let's say you ran 2 RPCs. So it's going to run in the same order if it's reliable. If it's not reliable, the order may change. Since it's networked, it's not instantaneous. So stuff like that can happen. So now I'll just make this reliable. I'll just go ahead and print a string and I'll call this one server RPC. So now what we can do is we can go ahead and we'll not do this set with notify. We can go ahead and instead of that we can call our set some float, and let's see if we get anything printed. Now something weird happens. As you can see, we are not able to actually call this RPC. If I were to actually play this and if I open up the output log here, as you see it says warning unit driver process remote function, no owning connection for actor BPA C1. This is basically the display name of the actor. Function some float, set some float will not be processed. What has basically happened here is that Unreal basically does not know which client actually owns this actor. Now this actor isn't owned by anyone. And if you were to notice this RPC call, it says reliable replicated to server if owning client. Now this if owning client section which is there, that is what is causing our server RPC to fail. Now let's do a similar drill but inside a character. So if I were to just create an RPC here, so I'll just go ahead and create a custom event, and I'll just call this one SV_test, something like that, and make this one a server RPC, reliable. Go ahead and we'll just print out a string and we can say RPC called from character. Now we want to be able to call this from the client instead of begin play, since we are in the character anyway, so we can use a more elegant solution, maybe on a key press, so maybe K on the keyboard because we don't have any other thing, so K on the keyboard. So find it over there. So there is K. So when we press it, this will obviously run on the client which presses the key. We can call SV test. So go ahead and play this. And if I go ahead and press K, it works on the server. And if I were to press K on the client, it works on the server too. I mean, obviously it's a server RPC, so the function will run on the server. But the point is our RPC worked and our client was able to make the server RPC. Now what if we wanted to be able to call this? So from a client. So for this, you'll basically need to have an owner for this. The way you do it is through the spawn actor function. So if you've just placed it in the level like that, you will have to use the set owner method, which again, I mean, if you were to place something in the level, it's pretty obvious you wouldn't have an owner for it. But let's just see an example where we use the owner. So what we can do is, okay, we already have a spawn actor function. And for the owner here, this is something which I did a bit later. So for the owner here, go ahead and plug in self. So spawn an actor doesn't matter, the location and stuff doesn't matter. We aren't worried about the actual actor itself, we are worried about the RPC. So make owner self, and now what I want you guys to do is run this only on the client. So let's say for example, we'll again do it on key press. So then that's going to be easy for us to manage, so we can manually call it. So on key press, what we can do, and we want to spawn this on the server obviously. We don't want to spawn this on the client because it is replicated, remember. So you have to spawn it on the server itself. Even spawning cannot be on the client. So make sure you spawn it on the server. So is server, only if it is the server, we are going to spawn it. And obviously this will run multiple times because for each player which will be spawned, this will run. So there's no way for us to actually ensure that it happens only once, but nothing to worry. So we can just grab a reference to this. And we'll need to make this replicated if we want access to it from the client. So we'll go ahead and promote this to a variable. And we'll call this one obj for example. And make this replicated so that we can access it from the client. And now when we press the K key, we can just check if it is valid. I mean, it will be, but just for a safety check, if it is valid, we can go ahead and call our RPC. I don't know what we called it. So we called it set some float. So we called it set some float. Go ahead and run this. Now if I were to press play and if I press K on the keyboard, as you see, we get server RPC printed. So if I were to check this, we have server RPC over here. And let's just test it on the client as well. So go ahead and press K. As you can see, server RPC is getting printed. So we are able to call it on the client. Basically, the ownership is important. Generally, it's a good thing actually that you wouldn't really require to call any RPCs from actors like this. Generally, you would have RPCs in your character, game mode, game state, stuff like that. Not in the game mode. Game mode, everything is going to run on the server. But for the most commonly used classes, networking is already set up for you. And in case you wanted to use it for an actor like this, I've shown you guys how to do it. So this is how you do it. Make sure you just set the owner. So let's say I don't actually set the owner, and if I go ahead and press play, this will still work actually. So if I press K, this is going to work. But if I do it on the client, it's not going to work. So that's one thing to note. From the client, the reason this won't work is because now that we do this, so let me just set the owner. When I set the owner over here, now when I press play, I have two characters. So one is on the server and the other one is on the client. And for both of these characters, the begin play is going to run. So this is going to run both for the server as well as the client. So for the first version, everything is going to run fine. But when this begin play occurs on the client's version of the character, even this character will have a begin play on both the server and the client, because since this is networked, this character will be spawned both on the server and the client. So when the begin play is called on the server for this one, that is when the owner property starts mattering to us. Over here, if we don't set self, in which case it will refer to this particular character in the game, our logic is not going to work. So that was pretty elaborate in my opinion. This is probably something which you wouldn't even require that much, but this is basically how you do RPC calls. Now there's one more type of RPC which I want to hint upon, and that is multicast. What if now that you're on the server, what if you wanted to print this for all the players? In which case it's really simple. Type in custom event and we'll just call this one MC underscore print. I mean, we actually didn't set the float here, which is kind of ironic, but we'll just do SV underscore print. So SV print. So we'll print this and we'll just duplicate this over here and make this a multicast RPC. Now, I generally don't prefer making these reliable. Generally, you would use multicast for things such as particle effects. So you wouldn't really need reliable, but anyways, I'll just do it for this example. And we'll call this one multicast. So we'll just call MC print. And remember, multicast RPCs have to be called on the server. If they're not called on the server, it will only run on that client. So it's not going to run on all the others. So if I were to press play, as you can see, we get multicast RPC. So this is basically how we would go about doing this. Now this worked on the server's instance, obviously because we spawned it over here. Otherwise it wouldn't work. So if I were to just go ahead and press play, you would see it works. And if we had more players, it's going to work again. If I had 3 players, it's going to print it multiple times. So it's going to print it on the server, client 1 and client 2. So we have server RPC, multicast RPC, and stuff works like that. So this is basically how you would go about calling RPCs. So you have SV print, which is routed to the server, and we can actually test that out rather than doing it on begin play. That is kind of an incorrect way. Obviously, I showed you guys the right way to do it. So this is some sort of logic which you would never use. So we'll just ignore all of this. Go ahead and press play. If I press K on the keyboard, you see we are calling the RPC. If I press K on the client, it works as well. If I press K on the other client, it works as well, and all of the players can see the printed string. Now you can also have the logic the other way around. So let's say you are the server, and then let's say, for example, I'm just taking an example here. Let's say when the game starts, you wanted to show a countdown, and the widget obviously will be spawned on the individual clients because obviously it's a widget, so it has to be spawned on the particular client's computer. So for that you will again use a client RPC. So I'll just do it over here. So let's say when I press the K key, we'll test this on the server itself. Client RPCs can only be run from that owning client or the server. If you run a client RPC from another client, it's not really going to work. So in order to do that, we'll just create an RPC. So we'll make this one CL_test and make this run on owning client. And what I can do now is I can go ahead and print a string and let this just be there. So if I do CL_test and if I were to press play, if I actually press K here, RPC called from character runs on the server. Over here as well, this runs on the client, and over here as well, this runs on the client. So this is basically how you do it. It'll just run on the client. But what if you wanted to run this from the server? So if you do this through a server RPC, it is going to be routed through the server. So I'll just do that and show you guys. So what we'll just do is we'll just DIY it ourselves. So we can say SV test, and this will run on the server. We can have another print string and we'll call this one SV for server. And over here, instead of that, we'll call the server RPC. And now what we can do is once this is printed, we can go ahead and call the client RPC. So CL test. Now if you were to notice, if I go ahead and press play, if I press K, as you can see, now both are called on the server. So the server RPC worked and the client RPC worked. But if I do this on a client, as you can see, the server printed SV and the server again called a function on this client. So this is basically how you would go about using client RPCs. So for any multiplayer logic, this is exactly how you would go about doing this. In C++, this logic is pretty straightforward. There are just a few additional steps for rep notify and replicating variables. But other than that, even the C++ part is pretty straightforward. So generally you would use Blueprint itself for core multiplayer logic unless it's something fundamental to your game and you want it to work properly. Like let's say you had like a firing mechanic or something and you don't want any sort of performance issues or any overheads, you would use C++. Otherwise you'd really just use Blueprint for most of the things because it makes things so simple. As you can see, you don't have to do stuff like opening ports and stuff. So all of that is handled by Unreal. And now let's go ahead and see how to run RPCs in C++. Now I've gone ahead and opened up Visual Studio. Now we'll just ignore the plugins part right now and we'll head into our source folder, beginner course, public, and we'll head into, first of all, we'll head into a character. Now what I want you guys to do here is, first of all, before you actually use any networking feature, just make sure you include net/unrealnetwork.h. Make sure you include this header. If you do not include this header, you will get all sorts of weird errors. So make sure you do that. Now, first things first, let's talk about variable replication. So if you want a variable to be replicated, you basically have to make it a U property, first things first. And this one will give the specifier blueprint read write as usual to make things simple for us. And one more thing which you have to give is you have to give the specifier replicated. And we'll make this, let's say, a float replicated CPP variable maybe. Now one more thing which you have to do This is additional. This is not something you have to do in Blueprint. But one thing you have to do for the replication logic to work is you have to actually write one function in the CPP file of our character. We'll go ahead and do that, and then we should be able to make this work directly. So I've gone ahead and opened up the documentation. So this is the function which we actually need. So we can go ahead and copy this and paste it inside our character.cpp file. So I've opened that up and I've just written a comment called replicating variables. Go ahead and paste it, and we can go ahead and have a definition for it. So over here, this is going to be a cpp underscore character. Just put your class name followed by the scope resolution operator. Then you can go ahead and just move everything to one line to keep things clean. And over here, you'd want to run this macro called doRepLifetime. And this takes in two parameters. One is the class, which is going to be our current class, and the variable name. The variable name is going to be this, or it's going to be replicated CPP variable. Now I'm recording this a bit later, but one thing that I forgot to mention is make sure you call super of this function. Otherwise, you'll get weird classes when you use the weird artifacts when you use the derived classes. And for the parameter, you can just pass this in. So make sure you just do that. Otherwise, your movement variables and stuff will not be replicated if you use your BP character. So that's one thing to note. And now if I were to go ahead and run a debugger, we should be able to do it. Just make sure you close the editor and then run a debugger. So as you can see, the build succeeded. And now we should be in theory able to use this variable as a normal replicated variable in Blueprint. So I'll just show you guys. Replicated variables are shown with those two balls on the top. So BP character is inherited from CPP character, so we should have it. So if I just type in CPP get replicated CPP variable, and as you can see, this variable is replicated. If I were to actually go ahead and check this variable over here, it says CPF net. This basically means it's replicated. So now this should work like a normal replicated variable. Now I'll show you guys how to handle RPCs as well. So RPCs are simple. I'll show you guys how to handle server and multicast RPCs. I won't really go over client RPCs. They work pretty much the same. So I'll go ahead and stop this now. And for RPCs in C++, you need to basically have a U function first of all. So create a U function, and you cannot make RPCs in C++ Blueprint callable. However, you can wrap them inside another function and then make them Blueprint callable or whatever. So what I'm going to do is I'm going to put the specifier server, and one more thing, I'm going to make this either reliable or unreliable. So this is where you specify it. So reliable, or you can make it unreliable. Now I can go ahead and actually write something here. So let's say void test server RPC underscore CPP, just to indicate that this is in C++. Now what you need to do is you need to define it over there, but also rather than defining this, you're supposed to define another function known as the implementation for this. So what we are going to do is we are going to just copy this over into the next line. This need not be a U function, and type in underscore implementation. Okay, just ignore the parentheses there. Implementation. And now what we can do is we can create a definition for this instead. So I've already done that. So I have the definition for this, and we can do something simple such as a print string. So uke is mid-system library print string, and we can go ahead and print in this is a server RPC from C++. Now this should in theory work. And if we want to call this RPC, what we would do is you can just go ahead and call this. We don't have to call the implementation, we have to call this in order for the implementation to get called on the server. Or we could just do something else, such as wrapping it in another function. So I'll show you guys both the approaches actually. So I'll just do it on begin play. So on begin play, what we'll do is we'll go ahead and we'll actually delete some of this code. So we delete this, and what we can do is over here we can go ahead and check. So if we are on the server, in fact, or if we are not on the server, we are going to do it. So if is server, so I guess it's called G is server. I think it's a variable, not a method. So if this is not a server, we are going to call this RPC. Over here we'll call test server RPC underscore CPP, and this will work as expected. And we can go ahead and wrap this in a blueprint U function. So we'll create a U function, make this one blueprint callable, and from here what we can do is we can just type in void wrapper for CPP RPC, and this one we can just write it like any other function and the RPC will run. Now what you can do over here is you can go ahead and run this function inside of that. So we'll go ahead and call this, and since this is blueprint callable, we can go ahead and just call this from blueprint. Also realize that just because of the way the function call works, this is not going to run at all. No matter what you do, it is going to come outside the if. So if it comes inside the if, it's again not going to, the condition is again not going to be valid, so you're not going to run this function. So anyways, we'll just run it as is, and then we can go ahead and run a debugger. So now if I were to actually go ahead and wait for it, so once it loads in and I go ahead and press play, if I press play right now, you would notice that you get this is a server RPC from C++. So we got two server RPC calls, one from the client and one from the server. Now I'll also set up some logic so that we run this during gameplay. So under your BP character, what we can do is we can run the wrapper. So type in wrapper for CPP RPC. Now if I go ahead and press play and press K on the keyboard, as you can see, it runs on the server. And if I do it on the client, that works as well, totally as expected. Now one extra feature which I want to cover in C++ RPCs is the validation. So if I just type in a comma and type in with, okay, I have my caps lock on, with validation, now what I can do is I can write a function which returns a boolean, and instead of underscore implementation, if I type in underscore validate, you can make it so that this function will only run under a certain condition. This is especially useful for something like cheat detection. So if I were to just create a definition for it, and what I can do is if this returns false, basically this client which is calling the RPC will get disconnected immediately. So I can just do return true for now, and this RPC is going to run. So if you had something like a health variable or something, and you do something like if health is, less than or equal to 100, and or maybe if you had any other condition. So let's say the health, you had a set health function which is an RPC, of course. So then you would check if it is less than or equal to 100, because you don't want the player to set the health to a value greater than 100. Stuff like this, but for now we'll just leave this to true. This function will run. Just to showcase, I'm just going to print string once again. So this, and we'll call this validate, and we'll not do this on begin play. So oops, print string. Go ahead and run a debugger, and before we do that, I'll actually just show you guys how to handle RPCs as well. I mean rep notify as well. So let's say I wanted to make this rep notify, I would use the replicated using flag. We'll do it after this actually. Now if I were to go ahead and press play, as you would see, the validate function was also called on the server. So the server is going to validate, and accordingly it is going to disconnect the client if the condition is not met. So that function, whatever we saw right there, that has to return true in order for the RPC call to take place successfully and for the client to continue stay connected. So this is basically validation. And now let's talk about rep notify. I am back inside the header file, and for rep notify, over here you can just go ahead and create a function. So what do we call this function? This need not be a U function, but you can make it as well. So we'll call this one on rep. It's just a convention to use on rep, but it need not be. On rep wrapper for CPP, let's say. For CPP. And this one will just be void. No need to return anything. You could return a value if you wish, but there's really nothing much you can do with it. Go ahead and write a function definition for it. Now again what we can do is we can go ahead and just print something. So we'll just copy this over, and rather than validate, we'll just print rep notify from C++. So now what we can do is, now we can feel free to come in here, and rather than typing in replicated, type replicated using equals and just pass in the function name. So you don't have to pass in anything else, and this is going to work as you would expect. One thing that you would want to do is, wherever you call this function, that will obviously be on the server, make sure you call this function as well separately. So where you set the variable, so we are setting this replicated CPP variable, so we'll do that. Make sure you call this as well. So if you're setting this in Blueprint, make sure you make this function a U function and make it Blueprint callable. So we'll do that actually. There's one issue with it in C++. This is how we would, this thing works in the same way as it works in Blueprint. So we'll just do it on our RPC itself. Anyways, we are running the RPC. So in the implementation for it, we'll not have the print string. Rather, we will have our rep notify. The way you do that is, we'll modify the value of the variable. If you modify the value, automatically rep notify will be called. Equals, I'll just type rand mod 19. I just chose a random number over there. And what you want to do is, you would want to call this function only over here, and the rest will be handled for you. Now we can go ahead and run a debugger, and you would see that rep notify will be called, and rep notify from C++ is going to be printed. It just works just like that. So wait for the editor to load in, and once we are inside the editor, if I go ahead and press play, as you can see, rep notify from C++, and it was called on the client as well. Since there are two versions of the character here, so one on the client and one on the server, both of them called it 2 times, so that's the reason we got 4 prints. And the same thing is going to work when we use the wrapper. So if I just type in K, for example, you see the rep notify works. So we get the validate, rep notify, as well as anything else that you would expect. So rep notify on the server and the client. And if you want to do the same in Blueprint, so you can go ahead and set our replicated CPP variable to something, and you would notice something weird. First of all, I have to do it on the server. So we'll do it on a server RPC. So SV test, rather than doing CL test, we'll go ahead and set the value of this variable, and we can do SV test. Go ahead and close this. And if I were to press K, let's just wait for it. As you see, this rep notify is only called on the client. This is not actually called on the server. So in order for rep notify to work, again, once you do this, you will have to type in on rep wrapper for CPP. So make sure you actually type that. So now if I were to go ahead and press K on the keyboard, you see it runs both on the server and the client. So this is just one extra step which you have to take in C++. That is if you have your replicated variable in C++. So that's about it for rep notify. I guess we have covered almost all aspects of replication. Multicast is something which I'll just talk about. So all the same parameters except over here you'd have net multicast. So don't mind the spelling, I mean the capitalization. So I have my caps lock on, net multicast, and this will work as expected. You can again have your reliable and validation and stuff like that. The rest of it will remain exactly the same. So you'll have your implementation and you can have your validate if required. But you wouldn't really have a validate for a multicast RPC. So I'll just go ahead and delete that. And